Great that you have made it here. Today we want to discuss two of the main challenges we as data engineers face in our data analysis projects. And first of all, who are we? I am Carsten. I'm working as a data engineer since 2017, mainly on the Microsoft Azure cloud using Python or TypeScript and SQL Server stuff. But I'm also good at playing table tennis with a frying pan. And with me is my colleague, Kevin. Maybe you want to lose a few words about yourself?
Yeah, of course. Thank you, Carsten. I'm Kevin Bollerhei. I'm a data engineer for since 3 years for Wintershall, working also mainly on our central data platform at Wintershall, where we gather all production data from all assets around the world, bring it into one place where we can curate it and build the baseline or the basis for all the fancy AI or machine learning projects that we currently have in our company. We're working, for example, closely together with IBM on projects like detecting when a well or a pipe will break and stuff like this. But we as data engineers are responsible for building the baseline basically to have the platform to build the AI projects on top of it.
Yeah, great. Our agenda, we will first talk about the data challenges we have faced, the solution we have opted for at the Wintershall Data Hub project, what we achieved, then a bit more details about the whole process, and then we will show you the architecture we have used, and for the remainder of the time, we will answer your questions. So we come to our first challenge. We call it the Alias challenge, and as Kevin already mentioned, we grab data from various systems, and we have a very simple example. There is a real-world object, let's call it well A, and we get production data, but there the name is well_A. Then we get emission data from a different system, always there, different naming, so it's here well:_A. And we also get data from a third system, and there the name is also different. So that's the first challenge we face as data engineers. And our second challenge, which we highlight as the hierarchy challenge, we have a department controlling, and they have a certain hierarchy, how to report data, and they, for example, combine the data from well A and well B to a field called Mittelplate. But then there is another department, finance, and they simply deviate from the controlling hierarchy and sum up data slightly differently. So in this case, they count up well A and well C to decent. So, and then, of course, what our usual work looks like is we as data engineers quite heavily work on stuff, and then the business approaches us, and of course they want to have certain numbers, KPIs. In this very specific example, they want to display emissions per produced oil and somehow link it to the number of workers, and of course we have to deliver end of business. And then, of course, a side note, there's a different way to sum up for different departments. And now it's our task. We know, it's going to be a long day in office. And to recap, we get data from different sources. The names are different in the different source systems, so no match between data. And there's also the problem how to count up data for different departments, for example. Usually, or the legacy solutions, they used static code. The developer had to map the different objects, usually very complex. So use cases were less scalable, and at the end, the business wasn't able to read the complex code. So we thought at our data project, we need something else, and we started a application called Master Data Consolidation App, where we try to tackle exactly these problems. So what we actually do is we get data from the different source systems, and we generate a master key for all the different entities from the source system. So as you can see here, the different source system objects are mapped to the exactly same key. And during our ETL processes, we simply replace the source system's key with our master key. And that means that this enables us to then easily compare data from various source systems. And also, to tackle the problem with the different hierarchies, we simply allow that different departments can have different hierarchies. So in this very specific example, the finance hierarchy is slightly different, but the key takeaway is it's the same master key. The only difference is that its parent entity now has a different master key. So what do we achieve by these two ways how to model and shape and reshape the data during our ETL process? Here we have a static view on a Power BI data set. And at the end, users can switch between the different hierarchies. And if you pay attention to the numbers, at the highest level, at the top node, short abbreviated WD for Wintershall Dea, the numbers won't change. But if you dive deeper into the data, you'll recognize that the data changes. So the calculation is totally at runtime, depending on the different hierarchies. Okay, so how does the process look in more detail? Usually, there's a user with a new report requirement, and this means you have to connect a new data source to your central data platform. And on our process is that the stakeholder has to obtain the connection details for the new source. He has to get to know the tables and the columns where we find the source systems entities. And with that information, he goes to the developer, and then the developer is able to create the ETL process to bring these new objects from the sources into a, we call it entity queue. And this is the blue part of the chain. And then the developer has already finished the first task for him, and it's then the subject matter expert who has to clean up the entity queue, meaning the subject matter expert has to decide which entity has to map on which one in in our corporate hierarchy. So there are two options. So there is maybe already an entry or an entity in our corporate hierarchy, and this new source systems entity is just an alias. We have built a web front end to ease this process, and the user then opens the web front end. He takes one entry from the entity queue, and he defines, okay, this entity already exists. In this case, it's Wietse from a source system called Synergy. This is about a security system. And he then maps this new entity into an existing one. In this case, you can see it's Wietse Plus. And then a new alias is created in our MDC system. But this alias maps to Wietse Plus. If there's a completely new entity from the source, which is not yet in the corporate hierarchy, the user, again, chooses the entity from the queue, then he says, okay, this is a new entity, and now he selects the new parent of this entity, and then he's presented with the parent entity, the entity itself, and an alias is automatically created. For us developers, now this data source connection is established, and now the business user or the stakeholder can tell us, okay, I need these and that fact tables. And the developer then extends the ETL and replaces the source system's key with our master key using our backend REST API. And as you can see, the whole process is not only now on the developer, but it's largely on the shoulders of the stakeholder or the business user. And that's what we achieved. We transferred a lot of the work we had to do previously as data engineers onto the subject matter experts. Our infrastructure is completely hosted on Azure, and it consists of a SQL database. We have a graph database for the hierarchy model. We have a REST API that can be used for us, of course, as data engineers, but also for data scientists to receive the master keys or, for example, the different hierarchies. We have built up a front end for the end user or for the business holder to map or create new entities in the corporate hierarchy, and the whole authentication, the authorization process is done using Microsoft's Entra AD. But of course, this is a very simplistic view on our hierarchy. On our application. If you want to build up a more reliable application, you need a bit more. So all of our code or our application is containerized. We use DevOps for software versioning and for automatic deployment of code. We have application insights for monitoring, log analytics to automatically create alerts whenever an error appears, and we automatically create tickets on DevOps boards. And we use Azure Function Apps for our ETL processes, and at the end, we can deliver and provide curated data sets on a storage account where the master key is already attached to all the data, and the end user doesn't have the problem with mapping data, as I've shown in the previous sketch, on his own, but it's simply joining the data using the master key, and the master key or keys match. And with that, we are through with our presentation, and we are open to your questions.